Hello everyone, my name is Cesar Aguirre. I'm a first year PhD student at the HTSI department, and today I'm going to be talking to you about the topic of the law of total probabilities, which is something that I hope that you will find interesting. We'll try to start from a point of view not too mathematical. We'll try to instead learn how to use the law of total probability instead of deriving it. Maybe in another video we'll cover how to make the derivation, but essentially we'll try to make it in a way that is digestible, and hopefully you can also use it in a way that you can understand what's happening around you in the daily basis. Well, first of all, I'll introduce very quickly the equation for the law of total probability. Basically, if we have an event A, we can say that the probability of the event A is going to be equal to the sum from I equals to 1 to n of the probability of A given an event Bi times the probability of Bi itself, with the condition that Bi must be independent. What do we mean with this? It means that Bi, B1 and B2 cannot overlap each other. Now, let's try to make sense out of this. First of all, maybe let me try to, and I will try to use a different marker because this is not very good, make a very easy visual representation of what this is telling us. We can imagine that our space, this might not be better, but that our space of probability omega is this particular rectangle. And we can say that we have like an event in the middle, like winning the lottery, we can say. We can say that that lives in here. That is our event A. Now, we can also say that everything that is outside is a complement, that in this case will be not to win the lottery. But what we're saying is that if we don't have information about A at all, we can actually kind of derive it if we have another event B or a set of events Bi that span the same space and are not overlapping each other. So this will be B1, B2, B3, and this small guy here will be B4. So basically what we're saying is that we can use the connection between B and B itself to find A without having any idea of what A really means. So I'll actually show you a very concrete example. Let me just move to this board in here. Okay, so let's say, for instance, that we're wondering if there is going to be any rain today during the day. So we want to know the probability of rain. That is like our big thing to look for. And we have two different applications, application A and application B. Application A says that there's a 70% chance of rain today, but application B says that there's only a 30% chance of rain today. And let's say that we want to find a very arbitrary point between using A and B. We say that we don't know exactly which one is better, so we're going to just choose one randomly. We're going to choose either A or B randomly, and we want to know, given that, what's the actual probability of there being any rain at all. So we're going to use the equation that we just derived, and we're going to say something like, first of all, we need to find ingredients, right? So the probability of rain given application A, we actually know it, is 70%, right? So it will be 0.7. Now, the probability of rain given B, we also know it, it's 0.3. And the probability of A is equal to the probability of B equal to 0.5, because we decided this way. We said that we were going to just choose randomly. We could have waited if it made sense, but in this particular equation, we just decided this way. So, as you can see, we actually have all of the elements. We can actually now say that the probability of rain is equal to the probability of rain given A, which is 0.7, times the probability of A, which is 0.5, plus the probability of rain given B, which is 0.3, times 0.5, which is the probability of B. And if you make this operation very quickly, you'll realize that the probability is in the end 0.5, which makes sense because 0.5 is 50%, which is in the middle between 30 and 70%. And in this way, since we have designed the experiment to be very fair towards both applications, it just makes sense to be in the middle. Now, maybe some other time we can look at some other experiments that are more hard, such as the Monty-Hall problem, which I encourage you to look at. But so far, this is the law of total probability. Thanks so much, and hope you have a great day.